Hey guys, today I'm going to go over how to solve equations with variables on both sides. So please make sure you watch this video where I fill out the first page of the study guide, then scroll to page 2 and complete those practice problems, and finally go to page 3 and check over your answers. Before we dive into solving these equations, let's just make sure we remember these vocabulary words. So in equations, some terms include variables. And a variable is a letter or a symbol that represents an unknown. So the terms -3x or y or 7z, these are all terms that include variables because there's a letter. Now, other terms are just constants. Now, constants are numbers that do not have any variables attached to them. So 3 or -4 or 72. And they don't just have to be integers, they could be rational numbers too, like 7.2. So today when we solve equations, we're going to move all the terms with variables to one side of the equal sign, and then we're going to move all the terms with constants to the other side of the equal sign. To see this clearly, I'm going to color code variables blue and constants a purple pink. My first equation is x equals 4x plus 21. I'm going to highlight the terms with variables in blue, and I'm going to highlight that one constant term in that pinkish purple color. Now, I see that my terms with variables are not on the same side of the equal sign. So my goal has to be to move them to be together. So I don't want that 4x to be on the same side as the constant. I'm going to have to move the 4x to be with the other variable on the left-hand side of the equation. To move a positive 4x, you have to do the inverse operation. So you have to subtract 4x from both sides of the equation. Then I'm left with -3x equals 21. Now you can see that all my variables are on the left, all my constants are on the right. The goal was to separate them. If you look at the color coding, all the blue is on the left, all the pink is on the right. The only thing left to do now is divide both sides by -3 and get your answer, x equals -7. For equation 2, we have 5x minus 20 equals x. The variables are not on the same side of the equation yet. So the first thing we have to do is to get those variables together. We don't want that 5x to be on the same side as the -20. So in order to move a positive 5x, you do the inverse operation and subtract 5x from both sides. Now I have the equation -20 equals -4x. I have separated my constants from my variables. All my constants are on the left, and all my terms with variables are on the right. So now I just have to divide by -4 on both sides, and I have my answer, x is 5. Equation 3 says 6x minus 30 equals 11x. This is another example where the variables are not on the same side of the equal sign. In order to get them on the same side, I'm going to take the 6x and I'm going to move it over to be with the 11x. To move a positive 6x, you have to subtract 6x from both sides of the equation. What this does is it gets -30 alone on the left-hand side of the equation and 5x alone on the right-hand side of the equation. Now that the terms with variables are separated from the constants, I just divide by 5 and I find my answer is -6. Equation 4 is slightly different than the ones we've already gone over. As I highlight, you're going to notice there's variables on both sides of the equal sign, but there's also constants on both sides of the equal sign. Our goal is going to be to separate the constants from the terms with the variables. It doesn't matter if the variables are on the left or the right-hand side of the equation, we just need to separate them from the constants. The first thing I do is I move the variables to be together. Usually I find the variable with the smaller coefficient and I move that one over. So in this example, 2x is the smaller coefficient. So I'm going to subtract 2x from both sides. After I move the variables to be together, I still need to work on the constants. My next step is going to be to move the constants so they're together. So to move -7, I'm going to add 7 to both sides of the equation. After this step, I have successfully separated the terms with variables from the constant terms. All I need to do is divide by 3, and I find out that x equals 10. Equation 5 is another example where both sides of the equation have terms with variables, but both sides of the equation also have constant terms. Your first step should be to move the variables so they're together on the same side of the equation. I usually find the variable with the smaller coefficient and I move that variable over. The reason I do this is because you avoid a lot of negatives, and it's really easy to make a mistake when you're dealing with negatives. To move a positive 3x over, I subtracted 3x from both sides, and I'm left with 13 equals 15x minus 2. Now I need to move the constants so they're on the same side of the equation. To move -2 over to the left-hand side, I'm going to have to add 2 to both sides of the equation. Then I'm left with 15 equals 15x. And you can see I successfully separated the constants from the terms with variables. I divide both sides by 15 and I find out that my answer is 1. Okay, last equation, this should be getting a little bit more comfortable. I'm going to highlight the terms with variables in blue. Notice how I include the sign as part of the term. I highlight my constants in pink, and I'm going to look at my variables first. I have to move my variables so that they're on the same side of the equal sign. So I'm going to take that -x and move it to the right to be with the 10x. That means I have to add x to both sides, or add 1x to both sides. And my new equation is 45 equals 11x plus 1. Now we have to focus on the constants. We have to move the constants so that they're on the same side of the equal sign. So I'm going to have to move that 1 over to the left. I'm going to subtract 1 from both sides, and my new simplified equation is 44 equals 11x. I've successfully separated the constants from the terms with variables. All I have to do now is divide both sides by 11, and I find out that my answer is 4. All right, now we're experts. Please try those practice problems on your own and check them over with your answer key. You can always come back to the study guide to see examples that were modeled for you.